Today we are going to discuss about traditional substitution ciphers. See, traditional ciphers are divided into two types, substitution and transposition. In substitution type, we will be replacing our plain text alphabet or any input with some other text. Whereas the transposition, we will be concentrating on the rearrangement of the plain text values. Okay, the plain text will be there, the alphabets which are there in the plain text will be available in the cipher text, but somewhere in a rearranged format. So we do permutations to the plain text, and the positions of the exact plain text will be rearranged, altered. Okay, so that is the concept of transposition ciphers. Now, in this section, we are going to see about some of the substitution ciphers. Especially in this video, we are going to cover Caesar cipher, monoalphabetic, and one-time pad. In the next continuity video, we are going to go with the Vigenère cipher, which is a polyalphabetic, and a playfair cipher. Okay, now let us start with the substitution ciphers. As the name indicates, we are going to replace with some other symbols, letters. Okay, now let us start with the first type of the substitution cipher. So that is called as a Caesar cipher. In Caesar cipher, this is a cipher where we are going to depend on the key value. If the key value is given, with k equal to 3 size, okay, our set of elements or the alphabet will be moving 3 times a forward direction. Okay, let me say my values are A, B, C. Now, if I give key value as 3, A will be replaced with its third value, that is B, C, D, right? So, A is plain text A will be written as D. Now, B, right? B. From B, you concentrate on the third value, C, D, E, right? So, B will be replaced with E. So, like this, we are going to form a ciphertext which is about to substitute with respect to the key value. This slide will give you a proper direction where we are going to concentrate on the Caesar. See, if you can observe, all the alphabet are given from 0 to 25. Then ciphertext can be generated with a plain text plus the key value. See, I said a value 0 plus 3. See, a value 0 plus 3 means 0 plus 3 is 3, right? So A is replaced with, A will be replaced with D. Right? See, A will be replaced 0 plus 3. So A will be replaced with D. Okay. Similarly, when we are going to apply the decryption process, we are about to find the plain text, right? So when we have plain text in our hand D, okay, ciphertext we have in our hand D minus your value 3. So what is the value of D here? So D's value is 3, right? So 3 minus key value is 3. So 3 minus 3 is 0. Mod 26 will give you the value 0. So at 0 I have A, right? So my plain text is back to me. Okay, got this? This is the concept of Caesar cipher. So whatever the content you will be getting, that we will be concentrating on the cipher with respect to the key value. But the disadvantage we have is the attacker will be trying all the possible 25 attempts on the given task. So that's the reason we are moving to the monoalphabetic cipher. In the monoalphabetic cipher, every instead of moving in a sequence, see, every time we are going to take plus 3 plus 3 plus 3, somewhere or other time we will be, our data will be eavesdrops or else released to the attacker. So instead what we are doing is we are giving a cipher value, key value with respect to the ABC values. So if I get anywhere as A, I'm going to write in D. If I get K anywhere in my plain text, I am going to write ciphertext as E. Okay, so let me write my plain text is if we wish to replace letters. I is a plain text. So I's ciphertext value is D, right? W, right? So I'm going to write W in the ciphertext. F. So find what is the ciphertext value I. So I'm going to write I. W. W ciphertext is R, right? So I'm going to write R. So like this, each and every value of the plain text will be having its unique some other alphabet, but not in a sequential format. Got this? So this is nothing but the monoalphabetic. Every individual alphabet will be having its own cipher value. But if any attacker tries 26 factorial times of brute force attacks, or else what are the redundant data we have. So depending on that, because English letters are going to repeat n number of times. See, we will be writing D, THED, n number of times. Okay, is, TO2. So these are some terms which are going to occur n number of times. So depending on that, what may be T cipher, they will be understanding. So after finding T, they will go with 25 factorial to the other elements. So this is somewhat taking time, but not as secure as we are thinking, right? So the next one is a one-time pad. This one-time pad is also called as, Vernam cipher. The other name of one-time pad, OTP, is Vernam cipher. Okay, so this Vernam cipher is a new technique which is about to find the plain text with the cipher text. Here the cipher, with the key value. Key will be equally sized with the plain text. Okay, key will be equally sized with the plain text. We are not concentrating on the individual alphabet, but plain text size, let me say if it is 15 alphabet are there, key will be also 15. Okay, so these are very, very important, where the key will be generated randomly, and this randomly generated key will be applied on the plain text to get the ciphertext. Compared to the prior two types of substitution ciphers, those are Caesar and monoalphabetic, one-time pad is somewhat better compared to those two. So let us see the working of one-time pad now. But the only problem in this is distribution of the key. Distribution of the key between the intruders, having a number of intruders in between, will be the major challenge here. Right. See the example properly. When I have 0 to 25 alphabets, see A to Z. Right? When I have A to Z, value in the plain text and add with key text. If the result is greater than 25, then modulo 25. Now, my plain text is hi, how. Key. See how many alphabets are there? 1, 2, 3, 4, 5. Yes. As I said, plain text and key will be always equal in size. So thus, my key is DWXCV. Okay. If it is 26 alphabet, my key will be 26. Got this? Now, plain text is HIHOW. Now, what is the value of H? What is the value of H? 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. In this manner, A, B, C, D, E, F, G, H, I, and so on. So now I got H, right? So H value is 7. Yes, it is 7. Now, I'm going to add my key value to the plain text. See, what is key value? D. So go to D and its integer is 3, right? 7 plus 3 is 10, right? The result is 10. So 10. What is the value of 10? 9ij k. Okay, value of 10 is k, right? So my ciphertext for H plain text is k. Got it? Next, I is 8, W is 22. So along with the sequence in the alphabet sequence from 0 to 25, I will be 8. Yes or no? I is 8 and W is 22. When we add these two, what is the value we got? 30. So what is the statement I have given prior? if the result is greater than 25, what we should do? Modulo 25. So that is the reason I have done 30 modulo 26. Sorry, 26 equal to. So when I do this, 30 modulo 26 is 1 the 26. My result is 4, right? So 4. What is 4 value? E. So the plain text I is replaced with the cipher text E. Similarly, H. H is 7 and X, its immediate key is X, 23. 7 plus 23 is again 30 modulo 26, that is E. Right? H plain text is replaced with E. Next, at last we have O and W. O value is 14 and C value is 2. So my value is Q, that is 16. Now 22, 21, 43 is the value, right? So when we have greater, what we should do? Modulo 26. 1 the 26. So what I got? 17. So the value of 17 is R. So thus how is replaced with KEEQR is my cipher text. Got this? Apply results. For the decryption process at the receiver, what we should do? Apply result in a reverse order. If we get less than 0, that will be in the mathematics of cryptography. We have studied how to deal with the negative modulo values. So that we have to apply. So how? Let us see. See, we have K here, right? We have K here. And at the same time, we have key value. The key value is DWXCV. Now, what is K? K is 10. Just now we have seen it. This is 10. This is 4 and this is 4. This is 16 and 17. 10 plus D. D value is 0, 1, 2, 3, 4. A, B, C, D, E. Right? See, 10 plus, sorry, 1 second. Yeah. 1 second. Yeah. So the decryption process, K value key, key QR, KWQR. Now, K is taken 10 and what we should do? 10 minus 3. What is 10 minus 3? 7, right? So what is 7 value? H. So my H value is back. Now, next one, I have 4. Value 4, right? 4 minus key value 22. So what is the output? Minus 18, right? So when I have applied negative modulo concept, see when it is less than, minus 18 modulo 26. So what is the value? 26. Sorry, minus 18, 26. So what may be the value we will be having? 8, right? So what is 8 value? I, right? Next, I have I here. So like this, we are going to decrypt back our data with proper mathematics of cryptography. Right. If you have any doubts in this session, just feel free to contact me at any time and or else comment in the comment section if you have any queries. Thank you for listening.